Hello everyone, I'm Amirhossein Ahmadnia, a PhD candidate in Pennsylvania State University, and today I'm going to talk about my research topic, a waste-based structure for an emergency shelter for you. First of all, I would like to say thank you to the Politecnico di Milano and Textileshub Laboratory of Politecnico di Milano. This research is a part of my master thesis, and I developed it during my research period in Politecnico di Milano and Textileshub Laboratory. The aim of this research is finding a path in order to balance between the problems of today's world from an architectural point of view, and also we are trying to generate a waste-based emergency shelter by upcycling the mismanaged waste material. No one can ignore the fact that a large group of people are suffering from lack of housing. United Nations High Commissioner for Refugees announced that at the end of 2019, 79.5 million individuals were forced to flee their homes. It has caused that the number of people who in need of housing to increase. And for sure, building an affordable house cannot be the best choice, especially for those who spend outside each night. Therefore, we need a temporary and emergency accommodation as a short-time action. Moreover, comparing the world population in 2020 versus 2050, we will experience an increase of 2 billion people. I do not want to talk about the different aspects of these goals, but I just want to highlight two crucial topics here. First of all, we need more resources for construction issues. We will surely produce more waste. All in all, the main question of this topic is, could the waste become a building material? The result of this investigation can open a new door in the construction world. Upcycling or creative use of waste materials can change not only the way we design a structure, but also the way we construct it. Positive environmental impacts, affordable housing, saving energy, protecting sea life, and protecting the human health are other positive aspects of this creative reuse or upcycling. The principal aim of waste-based shelter, as I mentioned before, is using waste material for designing and constructing. Simply, it can be divided into two parts. The waste-based shelter can be divided into two parts. Waste-based structure, which is the purpose of this research, and the bottom members are the main elements of it, and also waste-based membrane, which we are going to talk about it later. The material that we are going to use for our waste-based structure is waste plastic bottles. Previously, lots of researchers tried to use waste plastic bottle in construction field. EcoBrick, which is a bottle filled by other waste material or other substances, is one of the most famous examples in this field. Some research groups, such as PetMat, try to design a specific shape for bottles, and as a result, they are trying to design some furniture. Both of these cases using bottles not as a structural element. They are using bottles as a covering, like a brick. But the third solution is using bottle as a bottom member. Bottom member is a structural component that contains two plastic bottles which are connected together from the bottom part. I'm going to talk about it more at the end of this presentation. For the form finding method, we are considering 3D graphic aesthetics. Why 3D graphic aesthetics? Because 3D graphic aesthetics gives us the possibility to generate the best possible geometry, and as a result, it reduces the overall forces which are applied to each structural member, and we can use environmentally friendly material as easily. Also, it gives us the possibility to control the form and forces, and the role of the architect and designer in the final solution is not neglectable. Each design process needs some inputs and perception. Here, we are going to design a shelter, so we have to consider some inputs and perception. The first important thing is that we need at least 3.5 square meter for each person, considering that we are going to design a shelter for a family of 3. Also, the minimum height of this shelter should be 2 meters. Moreover, we are considering also the loads. We have a vertical loads, which can be a snow load, a stability load, and self-weight, and also we have a lateral load, which is more or less the wind load, equal to the wind load. And also, at least we need 4 supports. It's our perception, and also the shape of this shelter can be a dome shape or a half sphere shape. According to the European Code, the magnitude of the load were calculated and used to generate the draft of force diagram. The most important issue here is that the area of the resultant face should be equal to the magnitude of the vertical loads, and the area of the lateral face should be equal to the magnitude of the wind load. Also, the number of the pyramid faces define the number of subparts. Before starting to subdivide the polyhedral forces, two constraints were taken into account. The first is the fixed length of bottle. Hopefully, there is a reciprocal relationship between the form and forces diagrams in the 3D graphic aesthetics. The area of faces in the forces diagram can define the length of members in the form diagram. Therefore, in subdivision of forces diagram, thanks to the physics engine simulation, the area of faces were considered around the length of body. On the other hand, instead of considering the lateral and vertical forces separate from each other, we decided to consider the resultant force of these two forces. And finally, after the subdivision of the force diagram and also applying the two constraints that I talked about it before, we can generate the form diagram. Our form diagram, or in another word, the base-based structure, are completely related to the force diagram. Here, we are going to add another diagram, and we call it the material diagram, which specifies the type of bottle for each structural member. As I mentioned before, the length of bottle are fixed, but we are using three types of bottles here. As I mentioned before, we are going to use bottle member for our base-based structure. In order to connect the bottles and create the bottle members, we are using bolts and nuts. And also, in order to connect the bottle members together, we are using hubs. Hubs are 3D printed joints. In conclusion, the base-based structure is generated by using 120 base plastic bottles along with 50 hubs. It covers around 70 square meter, which is more or less adequate for a family of 3 persons. And I would like to say thank you for your consideration, and I would like to finish my presentation with this sentence that waste are tomorrow's resources. Thank you so much and have a nice day.